I have wanted to do mission work for a long time, so specifically on Europa Clipper. So I don't know. I feel very, very lucky that I'm in this position and got to see the launch and everything. So yeah, looking forward to whatever updates I'm allowed to share with people on social media. But if you didn't know, the Mars flyby is coming up, and that will be in March, around March. So look forward to that, and I'll definitely post about it. Like I said, I have rules of what I can and can't post about the mission, but like I said, I'll share what I can.
Thank you.
Yeah. I don't know how. Okay, hold on. Presentation. And I've given it before. I'm really excited to give it again. I'm just trying to figure out. Mm,
As a co-host, you should
Oh,
be
I
able to
see.
share your screen. So go down to the share menu, and then you'll just want to click the buttons to be
Zoom.
sure that it optimizes if your presentation has any video in it.
I've literally done this before, but it's also early here, so I'm like,
Well, we're fortunate
um,
also that one of our members, Mike Emery, is our local Zoom guru. So
oh,
if
share
you're
screen. Oh
having
my God, I didn't see that. I'm very tired. I'm
if
sorry.
you're having
I've
any
been so
trouble with
busy.
Zoom, Mike can help.
I got it. Yeah, thank you. I'll just do it's not letting me share. I can't hit the share button. I don't know what's going on. So I guess
Are you
Zoom.
working on a Mac?
No.
You're on a Windows machine?
Yeah.
Uh,
Like the share button is kind of grayed out. I don't know if it's because I don't have permission or
let's see. Well, you're a co-host, so you should have permission.
so
Uh,
then I'm not sure why it's grayed out.
Mike, I just opened the screen sharing generally, so try again now, Jasmine.
Okay. Nope.
okay, do you have another Zoom window open? Are you working with dual monitors? No? Okay.
Laptop. Yeah.
Okay, try it again because share screen was not enabled and then I enabled it, but then it disabled again. So now it's
Oh,
available.
okay. Oh, I mean, let's just send the if need be, someone else can share it and I can just tell when to switch slides. But I would have to send the presentation.
Yeah, if your
That's the
presentation is
only
any size at all, that
it's
email may not work too well.
yeah. Okay. Well, I mean, the only other thing is, I mean, it would waste time. I can leave and come back. Yeah, I don't know.
That's quite all right.
Okay, so you have the Zoom menu down at the bottom. Uh,
Yeah, like I said, I click on share screen and the share option is grayed out, and I'm not sure. Like only I can hit cancel. That's it.
Is it
okay.
possible, Mike, that this is in Jasmine's settings in her own Zoom account?
Uh, Not so much on a Windows machine. Windows
Yeah.
does not have the same level of security the way Apple does. Uh,
Roy, do you have something?
Oh,
so
sorry. No, I've been just pressing things, pressing buttons.
yeah, I can click on share and
It works.
it does come right
I
up.
I don't think my presentation is that large. It's only like 20 slides.
Oh, wait a minute.
So,
I see it. Someone opened a shared screen.
Yeah, I was just trying to see if what happens when I did it, and it seemed to work. That's why.
Yeah. Um,
Try setting your Zoom settings.
okay.
How large is the file if you want to email it in the meantime?
Um, let's see, I have it saved. Like I said, it's only 20 slides.
okay. I'm seeing if there's.
One second. It's only, yeah, it's not even a gigabyte, so.
Oh, that's still pretty big for email.
Oh, really? Okay.
Yeah.
Do you
Yeah,
want to just
anything over 100 meg on a lot of systems, you're gonna die.
Oh,
Yeah.
okay. Well, that's not gonna work then.
Okay, I'm looking
Mhm.
in Zoom settings on share screen and see if there's anything that pops out.
Or just try sending it to Jonathan.
Okay.
It doesn't work, it doesn't work, but it's
Yeah, it's worth a try. Yeah. I don't wanna keep people here too long. Okay, I'll try.
Jasmine, I don't know what this looks like on a Windows machine, but
Mhm.
when you click share and you get a window up, do you have to choose what you want to share?
Yes, and I can, go through it says Chrome tab or window or entire screen.
And if you
Oh, do I
click,
have to? Oh my gosh,
you
I
have to
wasn't.
click one of those.
Oh my
Yeah,
gosh.
click
I'm so
on
You have to,
sorry.
click
you
I
on
have to
slept
click.
really
PowerPoint
late
then.
last I
Yeah.
Yeah.
slept really late last night. Can you see it now?
Uh, yeah, it looks like you're.
I mean, I'm sharing Zoom, but I'm asking if you can just see it in
I can see
general.
Yeah,
your
yeah,
Just
desktop at the
yeah,
very
okay.
looks.
Is
there we
is it
go.
working?
Okay, there's
It
your
worked.
PowerPoint.
Okay. Wow,
Okay,
I'm
now
so
go
tired.
just
I'm so sorry.
yeah, now
I
just
literally just my semester just started this week, so
Okay.
I'm still fixing my sleep schedule.
That's
That
good.
was that was a brain fart.
All
Okay.
right.
no, Jasmine, that's what happens when you're stargazing too late in the evening, right?
Well, that too. I was looking at planets last night with my friends, so but it was worth it. I saw 5 planets. So, okay, slideshow from beginning. All right. Let me know. Can
Yeah,
everybody
we can
see?
see it.
Yep,
Yep.
we
Okay.
Perfect.
got it.
All right. Perfect. So, my talk is called, you may notice, called We Too Are Made of Water. That is because, fun fact, on the Europa Clipper spacecraft, there's something called the vault plate. Think of it like, if you're familiar with the Voyager missions, think of it like the Golden Record. It's kind of like a little plaque that's on there, and it has different things on there. For instance, it has the Drake equation. It has the best thing is it has one side that has different audio files of the word water in over 100 languages, which I think is kind of beautiful. And then it has various other things, but it also has it has a poem. And the poem was written by the US Poet Laureate. And it's a very beautiful poem. I recommend looking it up online. It's called In Praise of Mystery, a poem for Europa. Um, and like I said, it's a very beautiful poem. And one of the lines is "We too are made of water," and I thought that that was a very beautiful line in the poem, and kind of encapsulates kind of the whole point of this mission and everything. And when I was at the Europa Clipper launch with the team, this was kind of everywhere, like it was on the merch and stuff. So it's a very important thing to remember. So I just wanted to title my mission that. But like I said, go read the poem in your free time. I think it's very beautiful. I do have it in the presentation, but I'm not going to read it out loud. Okay, so yeah, this is the poem. I guess you can skim through it, but like I said, find it online and you can see this is the oh my gosh, I forgot where the line was. Oh yeah, we too are made of water. And I think, like I said, that's very beautiful. I did want to clarify. I mean, I think I mentioned it in the presentation, but um, Clipper specifically is not a life-seeking mission. So the point of Clipper is to assess the habitability of Europa because we can't detect life if, or we can't search for life if we don't even know if the moon itself is habitable. So, Europa Clipper is going to be doing flybys and stuff like that. So it's not landing or anything. But I'm very optimistic, and my hope is that if we get really good data from this mission, that we can have a future lander or something that can actually, touch down on the surface and maybe drill into the, ice and get the, go into the water or something. I don't know. The ice is very thick. That's the problem. But yeah, we'll figure it out. So yeah, I just want to clarify that that's, not a life-seeking mission, but it is still a very important mission. And like I said, I will go through why that is. So yeah, here's the poem, like I said, and I hope you liked it if you were able to read it in the time I've been yapping. Okay, so I just wanted to define a very important term because this is kind of a newer field. So everybody might not know what astrobiology is, but this is kind of the field that I am in. Even though that's not technically what my degree says, it's what I study. Anyways, so astrobiology is defined as the scientific study of life in the universe, including its origins, evolution, and potential distribution. So keep that in mind as I'm going through the presentation. Yeah, so our search for life in the solar system, in the universe, technically, we follow a principle called follow the water. And this is because, as we know, water is essential for life as we know it. On Earth, all life requires water to survive. So we kind of use that principle, that understanding, to search for water on other bodies in the solar system and, broader universe, because we have expanded this search to exoplanets and everything. The Contour was originally made for Mars, but we can apply it to other fine. But basically, it kind of helps us guide our search for life on other worlds. And I put a really good quote from a NASA page on the bottom: to truly understand the nature of possible alien life, we must directly investigate the source, the liquid water. So I will obviously go through further in the presentation. Europa has a lot of water, if you didn't know, but it is really important. And that's why this mission is one of the reasons why this mission is really exciting. So that's what Europa looks like. That's a really good picture. And I hope, obviously we're going to get more when the mission gets there, but that's about 5 years from now. So for now, we have ones like this. So why do we care about Europa? All right, so pieces of a jigsaw puzzle. So Voyager 2, when it did its flyby, it returned images of the surface, and scientists saw these kind of dark bands, which had opposite sides, and they kind of matched each other, very well, kind of like pieces of a puzzle, or think of it like the continents, because the continents were all connected at some point and then they broke apart. So think of it like that, the edges of the continents line up. So it's kind of like that. So what they had found out is that those cracks had kind of separated, and that dark icy material flowed into the gaps and it froze, and it suggested that the surface had been active, like at some point, geologically. So Voyager's images not only showed those bands, but it also showed a lack of craters on the surface. And as you may know, a lack of craters on the surface of any body suggests that there are processes that erase those craters. So obviously the moon, for instance, has a lot of craters because it doesn't have any, processes that can erase those craters. So Earth has a lot of processes that geologic processes that can erase those craters over time. So that's why we don't have as many here. And so it's the same idea. So not only that, but essentially they came to the idea that there was a liquid layer, some kind of liquid layer that was beneath the ice. Due to those fracture patterns on the surface, and they weren't fitting in the predicted manner as Europa orbited Jupiter. So that had to suggest something about surface being active. The surface could move independently from what was underneath. So Galileo, they made a very important discovery. So Galileo was like really crucial in making us care about Europa, making us realize like what was going on over there. So it saw that Jupiter's magnetic field was being disrupted in the area around Europa, which implied that there had to be some kind of induced magnetic field within Europa that was kind of interacting with Jupiter, and they were thinking that it was caused by some kind of electrically conductive fluid beneath the surface. And based on Europa's composition, scientists thought that most likely answer beneath the surface is a global ocean of salty water, which is important. And fun fact, it's currently believed that Europa's ocean contains twice as much water as all of the water on Earth, which is part of why people are really excited. I'm really excited. I mean, that's a large amount of water, obviously. So that makes it a very promising place to look for life. And this image is just, obviously we don't know exactly what it looks like under the surface. So this is just kind of a hypothetical interpretation of what it could be like under the surface. We have the ice layer and the plumes that come up from the ocean into space, kind of like on Enceladus, and maybe there are some subsurface lakes too. So this is the big ice layer, which we don't know exactly how thick it is. That's one of the things that Clipper is going to do, is determine how thick the ice is, how deep, how long does it take to get to the ocean. And then this underneath that ice would be the salty ocean, and then potentially, like I said, this is hypothetical. There could be hydrothermal vents like we have on Earth that could be a potential fuel source, nutrition source for any kind of possible life down there, because we have hydrothermal vents on Earth, and we have extremophiles and such that live near those vents. And then obviously we have the bottom of the ocean, so the rock ocean interface, and the eventually deeper into the moon, the mantle and stuff. So like I said, this is just a hypothetical plot of what the structure would look like. So hopefully when Clipper starts getting data in about 5 years, like I said, we can make a more detailed map. Also, I wanted to point out, if anybody has any questions, please stop me and let me know if you have one throughout the presentation. But if you want to hold your questions to the end or type it in the chat or anything, just let me know. Someone can alert me if something pops up. Okay.
Well, Jasmine, I actually do have a question.
Yes.
The thing I'm wondering about is, how did we first figure out that Europa had this huge subsurface ocean?
Yeah. So like I said, that is from, I would suggest Voyager 2 kind of started making scientists more curious about Europa because of all these things with the cracks and everything. But I would say around Galileo's time, because it discovered that there was that disruption with Jupiter's magnetic field. So something was going on with Europa, and then that's when they kind of discovered there was some kind of fluid beneath the surface that was kind of, electrically conductive and creating magnetic disruption. So I would say Galileo.
This reminds, we went to a Smithsonian talk many years ago, and
Yeah.
I don't even remember who the person was, but what I remembered was exactly what you were just mentioning, this idea that we could, one, even detect a perturbation in the orbit of a planet as big as Jupiter caused
Yeah,
by Europa. I mean, that's the wow factor to me. And
I
then
know.
to be able to say, to do this, it would have to have a magnetic field. Now, I think where I'm left is, are there people who can actually compute how much salt water would have to be to create the magnetic field to actually do this? Does that make sense?
Yeah. No, that makes sense. And like I said, we do believe, like I said, hypothesize that the ocean has about double the amount of water that we have on Earth. So I'm sure that we came to that conclusion because of some kind of calculations, like you mentioned. I don't know exactly how they came to that, but yeah. So I'm guessing that it is possible. And like I said, there are different theories about the thickness of the ice. Some scientists believe it's more thin. Some scientists believe it's up to like 100 kilometers or like miles thick. So, like I said, we won't be able to exactly determine that thickness until we get there because we have an instrument designed specifically for that.
Thank you.
All right, so now I'm going to transition away from why we care about Europa and how we kind of got interested in it and talk more about the specific mission, Europa Clipper, or the Journey to an Ocean World. This is the mission poster. I love it a lot. I have it hanging in my apartment. All right. So yeah, thank you to Galileo and Voyager because Voyager 2 provided the first images that were close enough to reveal that Europa's surface had those ridges and those cracks, which suggested some kind of geological activity in the past. But obviously, as I just mentioned, Galileo's findings really were the ones that paved the way for interest in Europa and eventually the concept of some kind of mission being sent over there. Yeah, it was a major driver for Clipper, along with Europa, which was selected as one of the top locations for exploration in the Planetary Science Decadal Survey in 2011. So, as you may know, there is the Planetary Science Decadal Survey, which comes out every decade, and it details different targets of interest. So I think recently the one that came out had Uranus as an option, the ice giants, because obviously we haven't gone there since Voyager. And Voyager only did flyby. They didn't actually orbit, for long duration or anything. So we don't really know much about the ice giants. So that's one of the targets that they have right now. But obviously, things could change and we could go somewhere else. But that's kind of what the Decadal Survey has. One of the things it has in it. All right. Yes, I just mentioned this. Contrary to what many believe, it's not a life-seeking mission. There are 3 primary science objectives. One that I kind of have been talking about quite a bit throughout the presentation, which is to determine the thickness of Europa's icy shell and how the ocean interacts with the surface, like what's going on down there. 2, we're going to investigate Europa's composition, which is actually the objective that I kind of work on, which I'll talk about a little bit. And then 3, we're going to characterize the geology of Europa. So basically, all in all, the main science goal of Europa Clipper is to determine whether there are places below the surface of this icy moon that could support life. Not essentially that have life that could support it, but like I said, if we find, some promising data, maybe we'll go back there. We'll see. The European Space Agency, ESA, their JUICE mission, the Jupiter Icy Moons Explorer, is going to go to Europa, but Europa is not the primary target for that mission. It's actually going more to Ganymede and Callisto, which I think is important because we don't, we should learn more about all 4 of the Galilean moons of Jupiter. So that one is going to Europa, but it's not the focus, obviously, because we have Clipper that's going to be there for a while. I'm pausing just in case anybody has questions. Okay. If not, like I said, stop me in the middle. It's fine. So here are some fun facts about the Europa Clipper spacecraft. Obviously, I'm not an engineer. I'm a scientist, but I thought that these were kind of cool to think about. So with the solar arrays deployed, which are, these panels on the side, and those were deployed very soon after launch. Europa Clipper spans more than 100 feet, which is about 30 meters, and that's about the length of a basketball court. That is NASA's biggest planetary spacecraft. So it is huge. And I wish I got the chance to see it in person. I have some friends that got to see it in person before it launched, and that's crazy to think about. It has 24 engines, and it's going to orbit Jupiter and make about 50 flybys of Europa. And it has 9 dedicated science instruments, which I'll talk about in another slide, plus a gravity and radio science. And at launch, it weighs approximately 13,000 pounds or 6,000 kilograms, and nearly 6,000 pounds of that 13,000 pounds, about half of it is going to be just the propellant. So it is massive. I don't think we, comprehend, just an aside, I don't think we can really comprehend the size of spacecraft. Like, I don't know if you guys are the same way, but I always thought, and this was like more when I was younger, I always thought that the Mars rovers were much smaller than they actually are. I don't know why. I think I just thought they were like really cute, kind of like Wall-E size. But then, when I found out that they're literally the size of cars, they're bigger than humans, it just changed my perspective. So I don't think we think about, because the average person can't see, doesn't have access to see a spacecraft or rovers or whatever in person, but I don't think we realize like how massive they actually are because we can't really tell in the photos. So yeah, it's just cool to think about. Yeah, so these are the instruments on Clipper. I have a slide that goes over roughly what each of them does. I'm not going to read all of them out, but I will say for fun, I focus on the UVS instrument because I have 2 advisors. One of my advisor is the PI of Europa UVS, Kurt Rutherford, and then I also work on mass specs, which is the mass spectrometer, because my other advisor, she's not the PI of it, but she is on that team. So those are just fun facts. All right, here is the timeline for Clipper. So like I mentioned, the Mars Gravity Assist is coming up. This says, around the end of February. It could be February, March time. So roughly you have an idea. It's coming up very soon. I'm super excited for what we can get from that. And then after that, we're going to have, and obviously the launch was last October. But after that, we're going to have the Earth Gravity Assist, which is the end of next year. So that's a while from now, but that's going to happen as well. And then using those gravity assists, we're going to be able to slingshot the spacecraft towards Jupiter. And eventually it's going to get into Jupiter's orbit by mid-2030. So basically by the time I'm done with my PhD, which I mean, it seems like a long time and it is, but I'm just excited because I'll be done by then. And then, a lot of, I think a lot of job opportunities and research positions will open up for Clipper because of data analysis and everything. So I think that the timing is perfect. So then after we get into Jupiter's orbit, there's a few milestones that we have. So the first Europa flyby is going to be in spring of 2031. And then around May, so a few months after the first flyby, we're going to actually begin the science campaign, collecting data and everything. And then the second one is going to be a couple years after that. And then a year or so after that, we are going to possibly end the mission and crash Clipper into Ganymede, which I did not know that was happening. And I questioned why, but then I realized that, because I questioned why they chose Ganymede, and then I realized that, oh, we can't crash the spacecraft into Europa because it could contaminate the surface. Like anything, if there's any life down there, we could negatively impact it. So I think they just chose a different moon of Jupiter so that we don't impact Europa. But that is really sad that they want to crush it. I don't know, but it could be beautiful in a way if you think about it. I don't know. I get sad with like Cassini and stuff, but I don't know. So yeah, that's kind of a rough timeline of the mission. You'll notice that it's only like 3-ish years, which is really short, but you have to think about the radiation component. Jupiter's radiation is very massive, and so over time, it can damage the instruments on the spacecraft, and so we can't really keep it out there for too long. I mean, you never know. We could extend it a little bit past 2034 if things go well. We have had plenty of missions and such that have gone way past their lifetimes. A lot of the Mars rovers, and including Ingenuity. And also Juno is a very prevalent one that wasn't supposed to be that long of a mission, but it's still going. So we'll see what happens. But this is, like I said, the rough timeline of before and after we get to Jupiter. So what kind of data can we expect from Clipper? This is, like I said, a rough graphic of the instruments and what they do. I wanted to find a graphic instead of just putting text. And also I think the graphic does a good job of really summarizing what each of them does and putting it in a simple way that, non-scientists and the general public can understand. So mass specs, is one of the ones I work on, and that will be kind of getting the atmospheric composition of Europa. And then UVS is another instrument I work on, and that's the UV spectrograph. And that's going to be working on finding the surface and plumes and atmospheric composition. So both of those kind of go hand in hand on finding composition of different parts of Europa. And then we have SUDA, which is a dust analyzer. That's also going to get surface and plume composition. The ECM is the magnetometer, and that's going to be getting properties of the ocean. We have PIMS, which is going to be focused on the plasma. We have REASON, that's the ice penetrating radar, which is going to be, sending signals to find out the thickness of the ice shell through radar. ETHEMIS is the thermal imager, and that's searching for hotspots. And then obviously we have cameras, EIS. Those are going to be kind of mapping Europa's surface in 3D and in color. So I'm really, really excited for the imagery that we're going to get from Clipper. And lastly, we have MISE, which is the IR spectrometer, and that's going to be kind of finding the chemical surface fingerprints. So this is an overview of the primary instruments on the spacecraft. So it's good. And each of those instruments has its own team and everything. So that was really fun to interact with different people on different teams when I was at the launch. It was nice. Okay, so what happens if Europa is habitable? So we do have to think towards the future. Because there could be promising results. And like I said, I am optimistic. Maybe I'm biased, but I don't know. I have hope. So, and if not, then I think it's going to tell us a lot about the icy moons of the solar system. So I still think, regardless of what the results are going to be, I think we will still get very valuable data from this mission. So what happens if Europa is habitable? So I've seen talks about follow-up missions possibly to Europa again to directly search for life if Europa Clipper's data and results are promising. So there could be a possible probe to penetrate the icy crust and somehow get to the ocean and sample that material and see what's going on in the ocean. This might be more difficult if the ice is thicker. Like I said, there are scientists that have theorized that the ice might be several miles thick. So I have no idea how we would easily get to the ocean if that's the case, but who knows? So that's, one of the concepts. And then we could even have submersibles to explore the depths. So think about like submarines on Earth. We could have an alien submarine, which would be really, really cool. And it sounds like, something out of science fiction, but we literally sent a helicopter to Mars and we're sending another one to Titan. So I think science fiction is becoming less fiction and more reality. So that's kind of a concept for that. And then I mentioned Juice before, and I think Juice is important to mention again because it is kind of Clipper's like sister mission. And one of my advisors also works on Juice, so I might do some stuff with Juice. We'll see. It's kind of in the talks right now. But Juice, or the Jupiter Icy Moons Explorer, it launched back in April 2023, and it's currently on its way to the Jovian system. And its objectives are pretty similar to Clipper, but it's going to explore multiple Galilean satellites of Jupiter, including Europa, obviously, but mostly focusing on Ganymede and Callisto. So I think Juice is also a mission that people should be paying attention to because it's equally exciting and it's going to 3 different moons. So that's kind of cool. All right. So this is just a little fun aside. You can track where Clipper is right now in the solar system by going on this link over here to the eyes of the solar system. Or you can just search it. Obviously, I have just search like NASA eyes of the solar system, and then you can select different spacecraft, actually, not just Clipper, but for the purposes of this, you can select Clipper and then see where it is, and you can actually like zoom out, and like it's really fun. I think everybody should go on it and look at it. And this is a sample screenshot that I took when I went on there, and it's fun because it also shows you, like, you can see Pioneer 10 in the back. It literally shows you locations of different spacecraft, like past and current spacecraft. So that's also cool. You're not only seeing like the planets and moons and everything, but also different spacecraft. And I don't know, it's kind of cool. Or, I have to do a self plug. You can follow my Twitter. I also have Blue Sky, obviously, and I have that's on the last slide and everything. But I do still use Twitter because I have quite a big audience on there. So I didn't want to give it up entirely. You can follow my Twitter to get mission updates. Like I said, I will talk about what I'm allowed to talk about. And obviously I'll talk about milestones and everything that is public information. So it's really exciting, and I love screaming about Europa and also space in general. So yeah. All right. So in the end, what are my thoughts? Because I am connected to the mission. I am hopeful, but I do recognize the uncertainty. But I do think that either way, the data is going to be useful to help us understanding not only this world, but also other similar icy ocean worlds in the solar system, and maybe even beyond, because we have found exoplanets that have bodies of water. So I think this is really exciting. This is a good, exciting era of space exploration because we are doing these astrobiology centered missions. So that's just, I don't know, it's kind of unbelievable now that we're like directly looking for habitable worlds and life and everything. I've always been passionate about that since I was little, but I didn't know it was called astrobiology until college. So yeah. I do believe that this mission is going to kind of pave the way to explore more ocean worlds. And it's going to put an emphasis on astrobiology when we're going to design future missions. I did mention Titan before, so we're going to have, if you didn't know, we're going to have the Dragonfly spacecraft that's going to explore Titan and investigate its habitability. Currently, that's on track to launch in the late 2020s, about 2028 or so, and it's going to reach Saturn in several years as well. So we won't see those results for a while, but it's still exciting that we're sending something there because that one's really cool too. It has like methane lakes and everything. So awesome. Yeah, so I talked about the vault plate. So this is a picture of both sides of it. So the top, I mentioned it shows the outer side of the panel and it has waveforms. That's the word I was looking for. Waveforms featuring the word water spoken in 103 languages, and it has this symbol in the center, which represents the American Sign Language sign for water. So I think that's just really beautiful. You know, it's kind of poetic in a way, just like the golden record. I really like when humans kind of send a part of ourselves out into the universe. Like, obviously, who knows if it's going to reach anything, you know? Like, in my opinion, I think there is life for sure out there, but it's probably far away. If we're talking about intelligent life, that's probably really far away. So I don't know if our stuff, you know, at the rate that it's going at, if it's ever going to reach anyone, but I think it's still beautiful that we're sending a part of ourselves out into the universe. So then the bottom is has several things on it. It shows the inner side of the panel, and it has the poem that I mentioned in her handwriting. It has a bottle, which has the over 2.5 million people's names aboard, which I hope some of you submitted your name for Europa Clipper, as NASA was advertising that quite a bit. Mine's on there. It has the Drake equation at the top written in his handwriting. It has the waterhole radio emission lines. And lastly, it has a tribute to planetary scientist Ron Greeley, because he was the one that really put an emphasis on Europa, like having a mission there and everything. So I would say he did play a huge part in getting the ball rolling for a Europa mission. So they put a tribute to him, which was really nice. All right, so I have yapped quite a bit, but that is the end of my presentation. If you have any questions, or we'll have a discussion afterwards. And I have my social medias, my primary social medias on here, my Instagram, my Twitter, and my Blue Sky. And you can also go to this page on the bottom, which is linked in the bios, if you want like all my fun links and everything. So thank you. Both of these pictures actually are from the Europa Clipper launch. This is literally when it was launching. I was so happy that my friend's mom was standing behind me, and I asked her to snap a quick picture of the rocket launching and me looking at it. And so I really like that picture. She was able to do that while I was recording a video of the launch, and then I sent that video to everybody. So it was a favor in exchange for another one. And then this is me. Like, there was a really cool setup of you can see Jupiter in the background. This is Clipper, and then the icy surface of Europa, and it kind of looks like they made it look like you're kind of standing on Europa, and then I was holding inflatable Europa. So I really like that picture too, and it was a really, really fun experience. I'm so grateful that I was able to go, because one of my advisors just happened to have an extra ticket, because I went, it was in October, and it was back before I was like officially on the mission, because I didn't officially join the team until December, because I was kind of in that process of joining at the time. So I was just grateful that she had an extra ticket and everything, because that launch was unforgettable. And just meeting the team and everything, and seeing how passionate everyone is about this, I'm really excited for the future, for this mission, and also just in general for the field of astrobiology. So yeah, exciting things to come. All right, so I'm gonna close out of this and go back to Zoom and stop sharing my screen. But I hope you enjoyed. I hope that was detailed enough, but also, I didn't want to go too in depth on like science and everything, because, obviously not everybody will understand that. And that's kind of not the point of it. I just wanted to talk about an overview of, how did we even get to the point of coming up with a mission for Europa, and what's Clipper going to do? What's the point of Clipper and stuff like that. So I hope that I gave a good general overview of Clipper, how we got here, and why we should care. So I hope this made you more excited for the mission, and hope you follow the updates and everything. So thank you.
Thank you, Jasmine. Yeah, I just think you're coming into the field at such an exciting time.
I am. I thought about this. I was talking about it with my friends. I regularly mention it to them. Like, I started my PhD in the fall, and like the fact that I started it a few months before Clipper launched, and then I'm gonna be finishing it when Clipper gets to Jupiter. I just think the timing of that couldn't be more perfect for me. So yeah, and also, in general, it is really an exciting time for our field. Just space exploration in general. I don't know if you guys paid attention to like the Blue Origin New Glenn launch or the Starship launch that happened recently. So I just think, it's just we're going in a great direction. So, I'm hopeful for the future, not only of human spaceflight, but also sending more spacecraft out there.
So maybe I can take advantage of asking the first question. And this is something I've been wondering about with all the attention to potential life in subsurface oceans,
Hmm.
far away from the old Goldilocks notion of habitable
Hmm.
planet.
I should have mentioned that. Yes.
What does it change our model, for looking for life?
I think that's why, yeah, I should have mentioned that. Yeah, it's good that you mentioned it, Jonathan. Yeah, so for those of you that don't know, there's kind of like a Goldilocks zone in the solar system. The reason it's called that is because it's the just right area for water to exist in a liquid state on a planet. So obviously, you have like Mercury, Venus, where they're much closer to the sun than Earth, and it's too hot over there, so can't have water. And then obviously, you have Mars, Jupiter, Saturn, so on, where it's too cold for water to exist. And so, in a liquid state. And so Earth is, in that just right area. It's just far away enough to where we can have liquid water on the surface. But obviously, since the Voyager and Galileo results, we found liquid water somewhere else, which is crazy to think about. But it is, underneath the surface, and the hypothesis is that through tidal heating, basically what that is like Jupiter's kind of pulling on Europa and stretching it a bit. So through all that motion, it kind of churns the inside and makes the water, like keeps the water at a liquid state. That's why it's not frozen um, underneath the surface. So yeah, I think that's really exciting. And maybe it does change the models because I don't think, prior to any of that, I don't think we really considered looking out past, Jupiter and Saturn at the moons, let alone, they're not planets, right? So I don't think before Galileo, Voyager, and such we considered those moons in our search for life. So I think this is going to change the game moving forward, and maybe it'll even affect the field of exoplanet science because that field is, rapidly growing and changing every day. And since we have, James Webb, which is really a monumental space telescope, and it's really helping us not only understand our own solar system, but also just much out there, So I think, yeah, I do think it is changing our understanding of things, which is why this field is fun to be a part of because it's like every day, not every day technically, but every year, every few years, you'll have papers and stuff that comes out that um, challenges our understanding of what we thought we knew in the past. Not only about planets and stuff, but just the universe in general. James Webb is breaking its own records, which is crazy to think about. And it's looking even further back into the universe. We're kind of seeing essentially the beginning, the earliest galaxies that formed, and figuring out what it was like back then. So yeah, it's really cool. That was my long-winded way of saying that. There is a question in the chat as well, but I'll wait to see if you have any comments before I address that one.
Well, the only thing I was going to say is with
Mhm.
Webb, again, so much of this is just mind-blowing.
It
And
is, yeah.
Webb's ability that is now being, refined
Mhm.
to be able to tell the atmosphere of distant
I know
stars.
the composition of the atmospheres of like really far away planets. That's just it's exciting, and we're finding things that, like carbon and stuff. That's really cool. So that's why I think, I am hopeful for my lifetime finding something exciting, and by something I mean life. Even if it's microbial, that's still people don't think about microbial life when they think about aliens, and I definitely blame Hollywood for that in all the movies. And kind of the sensationalism of aliens, but people need to realize that microbes, bacteria, that's life too. We humans didn't just pop up on Earth. Like literally we evolved from stuff like that. So I do think that um if we find even bacteria somewhere else, that's happy to me. Like I'll be good with that. That answers the question that we've kind of been asking for centuries at this point. So yeah.
Okay, Pi members, other questions or
Yeah, there's the one in the chat I'm gonna address. Someone said they're also a Purdue grad. Go Boilers. Have you shared this back to Purdue in any way? So, fun fact, yes, I did go to Purdue for undergrad. I majored in planetary science and double majored in atmospheric science, which is meteorology, because I wanted to focus my degree a bit. So, planetary science is a very broad field. You can study like whatever you want, like composition, geology, chemistry, whatever. And so I'm not a very geology oriented type person. So I did not, a lot of people do planetary geology. So we had a lot of people in our department that double majored with geology, but I didn't want to do that. But coincidentally, I did take the intro to atmospheric science class, and I did find it really interesting because I do think storms, weather, it's really cool too. So I basically after taking that, I decided I was gonna double major in atmospheric science. So I know a lot about the weather too, and I used it to kind of um, study planetary atmospheres, which is why, like I said, we're doing composition work now because it ties into my previous research and my understanding. But when I was at Purdue, that was when I actually learned about Europa and Europa Clipper and everything. So I did not share this back then because I didn't know. But I will say I did multiple, like after learning about Europa and researching it for a class project, I instantly fell in love and knew that that's the mission that I wanted to work on. Um, and so, like I said, I just did multiple presentations about it for class and stuff for class assignments. So I did a lot of my own research on it, and just everything I was learning was more exciting than the last. And that's when I knew I wanted to do this. And I did not think that in grad school I was gonna be able to work on the mission. I thought I was gonna have to do something else in grad school and then do it, work on Clipper after grad school. So I'm so grateful that I'm able to do it, 5-6 years, in grad school and then move on and hopefully continue it. So any other questions or thoughts too? We can have a discussion. I don't mind.
Oh, yeah, going back in the chat, Kevin Kelso asks, how does Saturn's moon Enceladus compare to Europa? Does it have the same
Yes, that's a
potential
great question.
for life under its icy surface?
I know a little bit about Enceladus. I think Enceladus is really cool as well, and we should send a mission there. We did have Cassini um, do some flybys there, and also, we discovered the plumes and everything, and we do have pictures of them. So I encourage you, if you've never seen them, to look at those because it's literally a geyser on another body, and you can literally see the material spewing out from underneath the surface. So I think that's amazing. So obviously there's the plumes and everything on Enceladus, and I think we should send something there to kind of sample that material and see what's going on. So it is pretty similar in terms of it having water and stuff under the surface. Europa Europa has plumes confirmed, but they're not like they were confirmed by like Hubble a while back. But they're not as common as the ones on Enceladus. Like the ones on Enceladus are like spewing out like a lot and so much so to the point to where that material contributes to Saturn's kind of outer ring. It's called the E ring. So that's how much influence Enceladus has. But Europa, they're not as common there. They might not even honestly, there is kind of debate about if it even has plumes or not. They don't even know. So we're hoping Clipper can kind of figure that out. I hope there are plumes, because that's really cool, and also we can use that to our advantage and kind of use Clipper to, find the composition. Like I mentioned, there's an instrument that would do that. So it's kind of iffy about Europa right now, but I think there are plumes for sure. I just don't think they erupt as often as the ones on Enceladus, and I don't think I don't think they're as like tall as the ones on Enceladus, because if you look up the Cassini imagery of the Enceladus plumes, it's very very tall. Because not a lot of gravity, so it's just kind of going out there into space. But I don't know if it's the same case with Europa. So I hope that
But
answered the question. Mhm.
will the Europa Clipper be able to detect it if it flies through one, or not so much?
Like the composition?
Yeah.
Yes, we have instruments that will get plume composition, including the ones I work on.
I think the other thing I wondered about was how far along is the technology for remote
Mhm.
sensing? In other words, to be able to sense under an icy surface.
Yeah, so I mentioned the radar, the ice penetrating radar instrument that we have, and so it is going to use radar and have those beams kind of bounce bounce out and then go back to the spacecraft, and it'll use that to kind of determine, okay, how much of what we just sent the beam to is ice, and then how much is water, right? So that's going to be our way of determining how thick the ice shell is without actually having to go to the surface and penetrate the ice, obviously. So I think we are at a pretty good point if we can be up in space in orbit and do flybys and be able to figure out stuff about the surface without even landing on it. Yeah, I'm not doing a lot of surface stuff, if you guys could tell, but I do think it's very interesting, and I want to try and do a little bit of the ocean stuff, like composition and whatever. We'll see if that's anywhere in my project, but yeah, I'm focused more on the atmosphere and the plumes and stuff rather than the actual surface.
Now, Rich McKinney said
Mhm.
the Apollo 11 command module weighed about 13,000 pounds. So it's kind of
Did not know
retroing back
that.
to an
That is
older
very
model.
impressive. Yeah, that is really impressive, and I mean, I always am thinking about the fact that like, our cell phones that we carry around every single day are more powerful than the computers that they used to launch man to the moon back then, so, technology has gone a long way, so I didn't know that. Thank you for sharing. That's crazy to think that the spacecraft weighs the same as that.
I think Diana has a question. Go ahead, Diana.
Okay.
Those instruments you described, will they be able to tell what the temperature of the water is under the ice? Or do you already have ideas about what that is?
Mhm. That's a really good question. I actually have not thought about that. I don't know if there's anything specifically that could do that. Like we know obviously that it's warm enough to be in a liquid state. I think it would be really cool to find the temperature, but I'm not sure what instrument would be able to do that given my current understanding of the instrument suite. Potentially maybe the radar one, I'm not sure. Or we're going to end up, I'm sure there's papers where they have guesses about it. I haven't read any because that's not what I've needed to read. But yeah, that's a really interesting question. I should look into that. Thank you for bringing that up. I'm sorry I don't have like a
That's all
detailed
right.
answer on that, but that's a really good thought. Now something I'm going to consider.
And the other thing was, how does the speed of the Clipper after the gravity assist compare to the speed of other previous missions?
We've used gravity assist in the past. I'm sure you guys know that.
Is it a
So the
standard
reason we,
speed can be
huh?
achieved, is what I'm asking?
I'm not sure about the exact speed, but I just know that the reason we do gravity assist, I mean, it's in the name. We use the gravity of other planets to kind of quote unquote slingshot the spacecraft towards its destination. So it really helps rather than it just going, you know, in a straight direction, for so long, So I think gravity assists are very important in getting us to our destination in a timely manner. And I definitely think they speed up the spacecraft, but I'm not sure like exact speeds or anything.
Pi members, any other questions for Jasmine?
Or thoughts or anything? Because I do welcome discussion. I like talking about what you guys think of everything. So don't be afraid.
And
But if not,
folks,
though, then that's
if I
oh,
can,
Diane has another one.
Yeah,
yeah, go ahead, Diana.
I can't help wondering,
Hmm.
like, what if Europa is totally covered by water, that there's no rocky prominence or anything like that? That would certainly, it seems to me, preclude being able to land there with any humans. Instruments would be different on ice, especially thick ice, but it would seem to be pretty uncertain to land human beings on a moon that has no firm land. So, I mean, I'm looking way into the future with a question like that, but
Yeah.
is there an
No, that's
indication that
good.
it is
Yeah.
totally covered by water and ice?
I don't think so. Like I said, we hypothesize. I think there's more of a general consensus now than previous years that the ice is pretty thick. But that doesn't mean that there isn't a lot of water. Like I said in the presentation, we believe that it has double the amount of water as Earth. And I mean, you guys know Earth is like 70% water, and we don't even, and the oceans are really, really deep, right? Um, so much so to where we don't know everything about them, which is crazy to think that we know a lot about space and our oceans are still confusing, but that's another story. Um, but yeah, I think you definitely bring up a good point. I don't know, at least at the point currently, if humans would be able to survive there because it's really, really cold. I
Right.
think Mars, at least at this point, Mars is probably the furthest we can go because the ice and gas giants, first of all, they're really, really cold and pressure and everything, and gravity is so much stronger. Not only that, but they don't have solid surfaces. So we literally could not touch down on them. The moons would be the only kind of hope. But like I said, it's really, really cold there. So I don't know if humans could even land there. And honestly, I think, I don't know if this is like a hot take, but I don't think so. I feel like if we discover life or like signs, even microbes, right, bacteria and such, I think we should just leave it alone. I don't know. I'm watching a lot of movies that we should just kind of leave
Yeah,
leave it
really.
alone and not contaminate the surface of another body, right?
Right.
Like a lot of people kind of have that idea with Mars, like, oh, we put the rovers there, so we're contaminating it, but so far we haven't found any life. I mean, we found really good things. Like we know to a pretty good extent that Mars did have water in the past because we found like evidence of river deltas and stuff like that. So we definitely know what Mars had water in the past when the sun was younger and not as hot. So obviously because of that, the Goldilocks zone would be extended a little further beyond Earth. So, Mars. Um, but I don't think we've contaminated it. At least I hope not. I think NASA's like tries really well not to do that, which is why they plan on crashing Europa into Ganymede instead of Europa Clipper into Ganymede instead of Europa, so we can leave it as it is.
Cheryl, go ahead.
Yeah, I'm just wondering if it's possible for you to bring up that picture that you like so much, that had a roundish. Oh no,
Oh, the one of Europa?
yeah. Was it
Okay,
Europe?
absolutely.
That one you really
Yes.
you
Yes,
want
it's a
to
really pretty picture.
take a
Yes. I
screenshot
got
of
you.
it.
Yeah, absolutely. This one? I
No,
feel bad because there's text on it. Oh,
I think
not this one?
no, it go down 1, 2, 3.
Oh, the mission poster?
Yeah,
Okay, absolutely. Let me
that's
put the full screen so you can get a better picture. Here you go. Oh, let me go to the. Here you go.
great.
Hmm.
Thank you.
Hmm. It's a really cool poster.
Yeah,
Yes,
I
it
love
is.
I
love it.
love um the silhouette of the spacecraft above Europa, and then Jupiter is in the background. Like, oh, that's a beautiful poster.
And I think I should say that
Mhm.
the biopic that you sent me of you
Oh,
standing
yeah.
up is the most interesting one I've ever used in making the meeting graphic for our meetings.
I appreciate it. Yeah, I remember when I sent it to you and you really liked the photo. I mean, that's my profile picture. I really like it,
Well,
and I wanted my
keep,
profile picture to be Europa related, so it works out.
keep that. Just keep that.
Oh, absolutely. I'm so happy. My friend actually took a bunch of them and she did a great job. She got like all the angles and everything. And I have one where I'm like throwing the inflatable Europa ball in the air. So it's just really cute. I had a fun time.
Well, while we're waiting to see if Pi members have any other questions for you,
Mhm.
um, I wanted to share
Mhm.
that in appreciation of your presentation today, we'll send you a very cool pie mug.
Thank you.
And
I
so,
guess I'll DM you my address if,
yeah, yeah.
yeah. Okay, David has a question or a comment.
Go
Yes.
ahead, David.
I belong to the Cosmos Club, and we have annually people in from NASA. And this year, we had John Mather, who's
Mhm.
NASA's senior project scientist for the James
Mhm.
Webb Scope. And they
Yeah.
bring a lot of pictures in with them of their latest findings and discoveries. And they talked a lot about black holes and how they suck in light and everything else and planets around them. And
Mhm.
then I guess I'm trying to find out what you know about them, because I took away from that they now know more than just black holes and what they do, but that they're actually uh, emitting new galaxies and new planets out of those black holes. Do you know if that's your understanding of it?
Well, I find black holes really interesting, and I have friends that research them for their PhD. Unfortunately, I'm not an astrophysicist, so that's not my area of expertise. Um, but I do know that James Webb and other telescopes and stuff like the Event Horizon one are continuously expanding our understanding of black holes. So I don't know, was that fact mentioned in the meeting or where did you
Well,
hear that?
I thought I understood them to say that, and I was sort of
Okay.
surprised because I know
Yeah.
that we know a lot of things are sucked into black holes, but
Yeah, but you didn't think it
first
was like
time I
coming.
heard,
Yeah.
or I had a feeling I heard that we now know that they're actually producing or emitting planets or galaxies out of those black holes. And I didn't know whether you had ever came across that or not, or
Oh,
your understanding of it.
I just Googled it real quick. Yes, they can. That is true. So that was a correct understanding. Now, do I
Okay.
know how that works or anything? No, but that is really cool. So apparently they can take things in and put things out.
Yeah, I don't think they knew exactly how it worked. It's just
Yeah, I
they
think we're
saw
still
that
trying to
as
understand
a
that.
brand
Yeah.
new finding.
Yeah, that's really cool though. I didn't know that. Okay. Well, yeah. Thank you for sharing.
Well, it's
And
just something I've become very interested in because they come in
Absolutely.
with some of the greatest photographs
I
and
love the James Webb
explanations of what's in
images.
them.
Yeah. Um, yeah, so I don't know how many of you follow my accounts. If you have Blue Sky or Twitter or whatever, I always post the newest James Webb images and just each one blows my mind like more than the last with just the quality of them and how much like because on Twitter at least you can
Mm.
load images in 4K and then you can zoom in like on your phone and oh my god, the detail with James Webb images in particular, even Hubble images too. I'm not going to discredit Hubble because Hubble was the predecessor and it walked so James Webb could run. And it's obviously still getting images after like 30 plus years. So we're not going to discredit Hubble. But yeah, the James Webb images are insane. And the data that we're finding, and we've only had it out there for a little over 2 years now, two and a
Uh-huh.
half years, is insane. So I'm really looking forward to what we discover in the future, not only about stuff in our solar system and galaxy, but stuff way beyond out there.
Well, and
yeah, these
they were
pictures,
talking about the launching of new telescopes.
Yeah,
One was
Roman, Nancy
Nancy
Grace
Grace
Roman.
Roman,
Hmm.
and the
Yes.
other one was a Habitable Worlds Observatory
Hmm.
for 2040.
Yeah, that one is kind of really far out because right now we have a faculty member that is on that team and it's in the early stages right now. But that one's going to be really exciting too. So I'm looking forward to it. Like I said, the coming years, decades. We have so much that is planned. And obviously, I hope, fingers crossed, that funding works out because the only way that NASA and other agencies are able to
Mhm.
do this is through sufficient funding. So I hope that funding works out and that we can do all these things and don't have to cancel anything or push things back.
Well, I'm envious that you'll probably live to see it, and I won't be around at that time, but
Oh,
good luck.
I'm sad. Well, you'll be in the stars. I always think about that with Carl Sagan. I love him so much and I wish I was alive when he was alive. Because he's like my biggest inspiration. And so I always, of course I'm sad that he's not here with us anymore, but I always try to think like he's become stardust now. We are stardust and we return to stardust. And I
Uh,
hope he is out there in the cosmos seeing, you know, what we've discovered.
well, thank you.
Oh yeah, no problem.
yeah, thanks for those words about Carl Sagan.
Oh yeah,
And
I miss him a lot.
I was just going to say that the star pictures, the space pictures that you circulate,
Mhm.
um, so I look at a field and I think these are stars, but every one of them are galaxies.
I know, because they look so small, and then you realize, wait a minute, that is not a star. It doesn't have the diffraction spikes or anything. And you zoom in, you're like, oh. never mind. That's a whole
Well-
galaxy. And then you see images like the Hubble Deep Field, James Webb Deep Field, that have hundreds, thousands of galaxies in there. And then you have to think about how many stars, how many planets are in those galaxies, which is part of the reason why I don't think we are alone. I don't know how there are people that think we are, because space is just way too big. And the odds, just statistically, the odds of us being the only life out there, whether that's microbial, intelligent, whatever,
When you get a
it's
chance,
just way too
tell me where
small.
exactly you want the
Sure.
bar.
Sorry.
Yep, go ahead. We just muted the what you were hearing.
Okay. Yeah, so I do not think we are alone. I think space is far too vast. And those pictures are a clear example of why space, is massive. And I think they give people a very good perspective on just how small we are. Like, I love seeing pictures of Earth from other planets. Like, there's the Mars one, there's the Saturn ones, there's obviously pale blue dot, most famous one. Even pictures of Earth from the moon, right? Just seeing it from space in general gives you kind of a different perspective. And astronauts often talk about something called the overview effect, which is kind of the emotions that they feel when they see Earth from space for the first time. They get very emotional and they start to realize, like, just how small we are, just how fragile we are. And then they realize, like, everyone that they love and all their friends and, just everyone in general is down there, on Earth. So that is crazy to think about how small we are. Hold on, there was a
Kim has a question in the chat.
Yeah. I see
I
Timothy's.
mostly work with the UV Explorer, but I wanted to ask what you could share about the magnetic fields, because that's really what triggered the suspicion that there is circulating salt water down there.
Yeah. I don't work with the magnetometer or anything, but I know that that's going to be really exciting, like what we find from that, because, like you said, that's the whole reason that I wouldn't say it's the whole reason we probably we did have interest in Europa before then, but that definitely sparked a lot more interest because we were like, oh my god, there's liquid under there, and that's crazy. It's so far out, and all that kind of stuff. So I do think the magnetometer is going to be really important. And recently, because Clipper launched in October, it's been deploying instruments over the past couple months during its journey. And one of those was the magnetometer boom. So the magnetometer boom has successfully, that's the little big like antenna that sticks out. So that has been successfully deployed along with a whole other suite of instruments. So I'm really, really excited for that. Like I said, I don't really work on it, unfortunately, but it will be very important, I will say.
Is it running and collecting data during the journey?
Okay, so what I know about
Earth and other flybys?
So what I know about my own instruments, UVS and such, is that we are, unfortunately, the timing was bad, but we did plan on like turning it on and like seeing, first light and like all that kind of stuff. But unfortunately, the fires were in California near JPL at the time, so they had to shut down and evacuate. So unfortunately, we could not do that. But I do know that spacecrafts in general usually turn instruments on and try to get data and like even pictures. I'm sure you guys have seen like a lot of spacecraft, like even what was it? I think it was Juice actually, had the Earth and Moon flyby and it took pictures, even though that wasn't really intended and everything. So we do test instruments a lot of the time, usually along the journey, because if we leave them off the whole time on the way there, and then when we get there years later, we turn them on for the first time and they don't work the way they're supposed to, or whatever, then that's a problem. So I do think it is important to turn the instruments on the way and test out everything. So that is what, according to my understanding, that is what we plan on doing. I think when we get to Mars, there'll be some exciting stuff coming. So stay tuned for a couple months.
Now, where did you say another helicopter is being sent?
Titan, Dragonfly.
Wow.
I think Dragonfly is supposed to be, I'm gonna make sure, but it is essentially gonna be flying, from what I remember. Yeah, it's called a rotorcraft, so I would consider it in that like general category, which is really cool. I mean, the fact that we even got one on Mars, obviously rest in peace Ingenuity because it's not going anymore, but it went for many more flights than it was intended to do. So
So
that shows, I mean, if we
how
can do
do
it
we
on
know what
Mars,
the
then yeah.
gravity is on Titan?
We can find we can use calculations and just find
Because
gravity on other
to
bodies.
create the helicopter, they need to know what the lift is
No,
going to be.
yeah. We can just use formulas, calculations to, with mass and everything to find out gravity. It's not, super crazy. And we also have technology to, help us with precise measurements from Earth and stuff. So yeah, using mass and everything, we can figure that out. Oh, yes. Okay. Yes, Rich made a good point. Yes, it is. I don't know why my chat keeps like scrolling up. Yes, it is. And it also has, like I mentioned, methane and ethane lakes on its surface. So that was really interesting to scientists when we discovered that. So that's part of the reason why they're sending something there. So I think that one's going to be cool. I mean, we don't really talk about Saturn's moons as much as Jupiter's. So I think it's important that we go to another planet's moons and see what's going on there instead of Jupiter's, because we already have currently 2 missions that are going to Jupiter's moon. So that's good for now. We should go to different ones that are icy and have water and liquid and stuff.
Do you have an estimate of the temperature when you get there?
Up real quick because scientists can do that. It ranges from -210 degrees Fahrenheit at the equator to -370 degrees Fahrenheit at the poles. Very cold. So that is about, oh, that's in Kelvin. I'm sorry, I don't do Celsius, but if most people here are American, then that's very cold. It says that the base of the ice shell may be at the freezing point of the ocean as well. So yeah, very, very cold. Which is why I don't think humans should go there, because we cannot survive temperatures that low. -200 to 300 degrees Fahrenheit. Yeah.
Yeah,
Actually, that brings up another question that I wonder if you've
Yeah.
talked or thought about at all, which is, given the advances in robotics and AI and all that, do you think it's likely that we're going to be sending robots on some of the missions that can more actively, manipulate things?
Are you talking about like landers, or I want to
Well,
make sure I understand like
right
what you
right
mean by like
now,
manipulate things.
well, right now, the Mars lander, has an arm and can do
Oh,
things.
like they drill and stuff?
Yeah.
Yeah, so I did mention that in the presentation. They have, obviously these are theoretical missions, but they have concepts for future Europa missions, and one of those would include like a lander that can like drill into the surface, and then another concept is like an actual submersible craft that can go into the ocean and actually like swim around and see what's going on. But like I said, that one's a little more complicated because currently, since we don't know exactly how thick the ice is, it could be very thick. And if it's like miles thick, I am not sure how we would get a lander drilling so many miles down to get there. I mean, maybe we could, but it would take a while. So that one's a little more complicated. But I would think having a lander on the surface drilling into the ice is very possible. And like I said, we'll see what comes out of Clipper, so that is possible. Because if we get good stuff, I'm sure people will have that interest to go back there.
Well, I'm thinking of, the robot hopping off the lander and bringing its own drill to do something.
I'm sure we can do that. Thank you, Rich. Um, yeah, I'm sure we can do that. It seems very possible. Like I said, with the way that technology is going, if any of you saw the Starship launch and the catch, like I know obviously there was an explosion and everything, which does suck and all, but they did do the catch, and
The
that is
chopsticks catch.
yes, and to me that is like obviously I'm not an engineer and everything, but to me that's like a crazy concept. And the fact that they are able to successfully do that blows my mind. So I think we are at the point where technology is getting there. So we could certainly have a lander that just drops down and does stuff. So I'm pretty sure that's how the concept would be too, similar to that.
I remember when the coolest thing for me that was what used to be science fiction is now real is
Exactly. I mean,
when
is that
SpaceX
not true?
is when
Yeah, SpaceX
SpaceX
is doing that,
landed.
and
Do you remember with the Heavy that they had the first stages on two sides, and they
mhm.
landed both stages across from each other? Do you
Yes, and
remember
it's just
that?
like
I
yes.
remember looking at that thinking,
Yeah.
okay, science fiction is here.
No, seriously, and that's why I think, like, it's crazy. We flew a helicopter on Mars. We can catch, the SpaceX is doing the catches, and we're sending another helicopter type thing to a moon. Like, we have Voyager that's going way beyond, the furthest man-made object out there. So, like, I just think, and that was a long time ago. But it still blows my mind the fact that we can communicate and fix, because they had, issues with Voyager 1. The fact that we can communicate with them and fix them all the way from Earth, even though they're like billions of miles away, insane. Insane to me. That is science fiction coming true. So I think it's only going to get better and more exciting over the coming years and decades.
And I think we can um, uh, uh, get you out of here in plenty of time for your next thing.
Yes. Yes. Thank you for remembering.
Folks, any last questions for Jasmine? And
If
Jasmine,
not,
again, will
okay. Mhm.
send me a snail mail thing, and we'll send you a pie mug.
Yes, thank you. Send me a just a DM on Blue
Okay.
Sky to remind me. Yeah. But yeah, thank you everyone. If you want to follow me and you have any more questions, you can DM me on Blue Sky. I don't unfortunately have DMs open on Twitter, just I was getting way too many. It was hard to keep up. So you can contact me on Blue Sky or Instagram, or I also have a blog which I have on my to-do list to update it. It's been a while, so unfortunately it's kind of out of date. But it still has good articles and stuff, blog posts that I wrote. But I have a blog, and you can contact me through there as well, or email me. I didn't put my email in the chat. I guess if I can put it, you guys can also email me. But the way to contact me on my blog, it does send me an email. But if you guys just want me to put it here.
Actually, could you put in the chat all of your contact stuff? That would be good.
Yeah, go ahead. Yeah, or I said go ahead. I'll do that. Sure thing.
And folks, where some people have already left, if you haven't yet signed up for the Pi Attend, do that, because we'll be drawing the door prize for the meeting very soon. Yeah, what we do, Jasmine, is send around the chat after the meeting. So if you
Okay.
have
Yeah, so that the people that
your
didn't.
contact stuff there,
Mhm.
that way everyone will have it.
Yes, I put everything. Most of my handles are pretty similar. It's all some variation of Astro Jazz. It's just some of them have underscores, so just keep that in mind. Thankfully, I joined Blue Sky kind of early, so I was able to get my tag on there. But Twitter and Instagram, you have to put underscores, and Instagram has two and underscores, and Twitter has one. So keep that
Oh,
in
so
mind.
you have the handle that makes you sound like an astronaut. Do you think you have
I do.
any
It's
desire
funny
to do
because,
that?
huh?
Do you have any
Okay, people do
desire
ask
to
me that
be
a
an
lot, but
astronaut?
I will say the story behind Astrodaz is technically it's a nickname that my one of my close friends gave me, so I like always kept it. And I didn't know until I made the Twitter account that astronauts also have astro underscore whatever their name is. So that is funny. A lot of people do ask me about being an astronaut. I think it would be very cool to go and see Earth from space. Like I said, it's a very life-changing experience, and the fact that I am at the stage of my life where I know people that have gone to space because we have more commercial programs kind of starting up, that is mind-blowing to me. Um, but I am I would be a little scared. I think that's the part that stops me is a lot of like it takes a lot of physical and mental strength to get there. To do the tests and everything that they have to go through. Um, so if I was to go, I think it would be maybe on like a commercial one or something where it's easier because like NASA, becoming a NASA astronaut is very, very difficult. So I think once if space travel becomes more accessible in the future, something I could think about. But I don't know if I would like stay in orbit or anything. I kind of just want to do like the where you go up there and come back down for like a few minutes. Yeah, that sounds better to me. I couldn't stay up there. I like touching the ground.
Well, again, thanks so much for coming to our meeting today. This was a
Absolutely.
wonderful,
I hope
wonderful
everyone
talk, and
enjoyed. Yeah.
it was so much fun for us to meet you and hear about your career. And now we'll all be following you, Jasmine.
Thank you. I appreciate it. And I'm glad you initially connected with me on Blue Sky and asked me to do this. I want to do more talks in the future. Like I've done some in the past, but it's kind of like gotten less over time just because I've been very busy. But I appreciate it and I'm happy to come talk about other stuff if you want. But yeah.
And if I could add one more detail about it,
Mhm.
we are so lacking in science writers. In other words, people
Okay.
who do the science but still can communicate it in a way that people can understand.
I'm
And
trying to
this
be one of those people.
and this is you. This is so you.
Thank you. I definitely, like I said, I mentioned Sagan before. I take a lot of inspiration from him, and I really liked. I think a lot of people like the way that he talked about space, or the cosmos. He sounded very poetic when he talked about it, and it was just so beautiful. Like if you look up any of his quotes online, even the pale blue dot speech, like that was so beautiful. And so I kind of take inspiration from him in the sense that I try to make it easy to understand, but also beautiful in a way. Um, so yeah, I hope I do a good job of making people understand more about space and appreciating it. That's the whole point of what I do is I just want more people to appreciate it, um, because it is very beautiful and we should all look up every once in a while at night, given provided that your skies are clear enough.
Have you had the opportunity to engage young people, before?
Yes. Yes, and that I will say kids are my favorite audience just because their questions are so cute, and they're very imaginative. So they can just ask anything wild and it's just I love it. I love that. So I do want to work more with kids in the future and hopefully inspire um the next generation of scientists and also more women of color like me, because we need more in our field. So yeah, I mean, they don't have to go into space specifically, but anything in STEM, I hope I can inspire kids to do that.
Well, I'm excited by what comes next for you. So thanks
Thank
again.
you. Yeah, no problem.
Yay.
All right. I don't know if I should go. Is it done? Yeah, have a good rest of your day, everybody. I look forward to connecting with you guys on social media. Bye. I don't know if we're ending it. Okay.
Bye-bye, Jasmine.
Bye.
All righty. Well, let's quickly do the door prize. And is Ginger still here? Yeah, I think she is.
Yes, I had to
So
unmute.
yeah,
Hi.
so Ginger, you're the winner of the door prize for our meeting today.
Oh, thank you.
So would you like an AirTag or a $25 Apple gift card?
Oh, how about a $25 Apple gift card?
Perfect. Roy, can you send Ginny, Ginger
Yes,
a gift card?
yes.
Oh, thank you, Roy. That's really sweet. Thank you so much for reaching out to Jasmine. It was fantastic. Really, really a good talk. And we are going to try to connect her up with the Aspire Learning Center here in Arlington that does a great job with underserved kids and has a great after school program. She might like to talk to them too. So,
Well, Ginny, I'll send around the 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 Zoom chat text, which has all of her contact information, so you'll have it. Okay.
great, great, wonderful. Thank you.
Van, do you have anything you would like to announce or say? Mr. Pi President?
No. Or
That
let me
reminds
put
me,
that, another way. No, I don't think so.
do you remember was that the Truman story or who was I think was it Truman? Or who was it? A couple of people came up to him and said, um, uh, what was it? You know, it was some story of a two-word answer by a president known for their lack of wordiness.
I don't remember. You got yourself into it, Jonathan. You'll have to get yourself out.
Yeah, so I think that as usual, what I rely on at a moment like this is say, I'll include it in the Zoom text chat.
I think it was Coolidge, but I don't remember the story or what it was he said.
I
And
think
the
it was
story was somebody bet Coolidge that he could get him to say more than 3 words at one time, to which Coolidge responded, "You lost."
Yeah,
right.
that was it.
Thanks, thanks,
There you
Jim.
go.
Okay, folks. Well, I want to say it's here in Silver Spring, it's at least a little warmer than it has been. still pretty chilly. So go out and enjoy the rest of the day. And we'll send around the Zoom chat. And Roy, thanks so much for sending Ginny the electronic Apple gift card for the door
Hey,
prize today.
hey, you mentioned weather. It caused me to say, if you're running Sequoia, is that the latest operating system? I guess it is. If you're running Sequoia and haven't done it, you might consider you can put a weather widget in your menu bar as part of Sequoia. I don't know if you guys have found that or not.
I'd like to try that. Where is it?
It's in setting. You go to settings. Oh, hold on. It's not in the control center or anything. It's in settings. So settings, probably desktop and dock.
So many things are in desktop and dock, you know?
That's, I think we're at desktop and dock, maybe where it is. Hold on. It's a specific thing. I should search for it
Widgets.
there. Did you find it?
Desktop and dock, with desktop and dock. And then in that is a widgets menu of some
Yep.
kind.
Yeah. I have to search for it, but that's where it's in settings somewhere. I just don't know. Anyway, now I should have been prepared. I thought I'd sneak it in there and leave it for you to figure out, but I should have looked up where it really was. Okay, I should be able to search for it, right? I should be able to search for weather right in the, no, that didn't work. Well, nice try, man. It's a toggle, you just switch it on and you have a little weather widget right in your menu bar. And when you click it, it'll drop down your selected locations and then you can also open the weather app from there. If you're interested in weather and want to have it handy, it's worth finding out where to put it.
Okay, I think I have it. If you are in settings, you turn on widgets. Okay, and then you can have them show widgets on desktop and in Stage Manager. I have both of those checked. Then I can go up to the top and on the far right, click on the date and time, and that brings over the widgets, and then I can get down and click on the weather app. Is that what you're talking about?
No, I'm talking. No, that was good. Well, you did better than I did. I'm fumbling around here. No, this is actually a toggle in settings that actually puts a little item in the menu bar. And mine shows sunny and 33 degrees right now. And it's right in the menu bar. All right, hold on. Okay, that's this. We got to find it before we leave. Okay, so let me do this. I was just going to search for it.
You can edit widgets and then decide on what widgets you want to include, and then where they're going to be also. But I don't see them in the menu bar.
Well, I'm looking at it, so I know it's possible. Go to System Set. Okay, here we go. You go to System Settings, Control Center, not Desktop and Dock. System Settings, Control Center, then scroll down to almost to the bottom, and there's an item that says Weather, and you can click to have it show in the menu bar or not. So settings, control center, weather. And then once it pops up there, you can then left click it.
See you next week, guys.
And it shows you your stuff. You got
Thanks, Jim.
Sorry, Jonathan, that was supposed to be really quick, but it was a little complicated. Sorry.
That's quite
Okay,
okay.
yeah, I just added mine. Okay. All right, cool.
Yeah.
Yeah, 34 degrees and sunny.
Jonathan, can you look at chat?
Oh, let me send you her.
I have her email, but
Well, Roy, I'll look for her. Okay.
okay.
So, Mike, you sent us a an astronaut page.
Yeah, I thought I had sent that to you, but I guess just went out everywhere. He is an astronaut who's actually from this area. In fact, Roy may very well know his parents, Brandy and Anita Lindgren at Lord of Life Church.
Right.
He uh, did a presentation at Ollie uh, a year or two ago, probably a couple of years, and the presentation mainly was about living in the space station, what it's like, what you go through each day, how you do different tasks. I don't know if that would be something that would be interesting for the pie, or if the pie group would be maybe too small for that. Uh, but perhaps uh, if you go through, he's out of Houston, and there's a public affairs office at Houston, and that may very well be able to give you access to someone else who could do a presentation of some sort.
Well, Mike, it might be a fun thing for one of our hybrid meetings if he's actually in the local area.
Well, no, he actually lives in Houston. He's from
Oh,
here,
oh,
but
okay.
yeah, but he lives in Houston. He did his presentation from Houston, and uh, unfortunately, he could only do it via Wi-Fi, which wasn't really that great. His signal wasn't good, and just a number of other things. So I'm not sure. Uh, it's mainly because that NASA would not allow any uh, software that's not authorized to be on their network.
Right.
So he had to do it at home and over Wi-Fi, and that wasn't great, but it worked out okay.
So this guy was actually born in Taipei and mostly grew up in the UK.
Well, yeah, I'm not sure exactly when his parents, uh, came to the States and lived locally, uh, but uh, his dad worked at did he actually work at? No, I don't think he worked at NASA. He worked at somewhere down in L'Enfant. Uh, I ran into him a couple of times with myself being on and off VRE at the station and whatnot. But yeah, it's yeah, I guess he comes back here every once in a while.
Well, thanks, Mike. Uh, folks, let's call the meeting to a close now. And thanks everybody again. Mary, always so good to see you.
Okay, thanks.
Mary has her earmuffs on. Bye.